Now the shortest distance between two lines. See, if we have these two lines, if two lines they lie in a space, any space, if they intersect at some point, then we say the distance between them is 0. Shortest distance is 0. But if two lines they are parallel, the shortest distance is what? The perpendicular distance between them. That is the length of the perpendicular drawn from one point of this line to the another point. But in space, there may be line which may neither be this way or nor be this way, neither intersecting nor parallel. So these pair of lines, if they are not in single plane or not in one plane, they are called non-coplanar, and these lines are known as skew lines. Right? Just consider this room. Say it has some size 132, and we have this size XYZ. So just join these two points. Just join these 2 points. They are neither parallel. They will never intersect. They will never intersect. This is what I wanted to say. So these are skew lines. So how to find the distance between two skew lines now? We have lines in different planes. They are neither intersecting nor parallel. So in order to determine the shortest distance between two skew lines, if we say L1 is this, L2 is this, L1 can be easily represented by A1 plus lambda B1 or by A2 lambda mu B2. Now take any point, say S, on this L1. Let A has a position vector A1 and this T, okay, T on L2, say position vector A2. So now the distance, the magnitude of the shortest distance between the vector will be always equal to the projection of this ST along the direction of the line of shortest distance. So we just have to take the projection of this line on that shortest distance. So if this PQ is the shortest distance between say L1 and L2, then because it is perpendicular to, because two lines, perpendicular distance is the shortest distance, because now this line is perpendicular to B1 and also perpendicular to B2. So we have a unit vector n cap along some PQ, which will be what? Which is perpendicular to B1 cross B2, which will be perpendicular to B. This is B1, this is B2, perpendicular to both of them. So B1 cross B2 by B1 cross B2, this modulus, or you can say the magnitude. So what will be PQ? It will be simply D distance into n cap, the D into n cap, right? PQ will be nothing but this is the n cap, that is the direction of that line. Now D is the magnitude of the shortest distance. So getting the vector, that is D into n cap. So let us say that there is a theta angle between ST and PQ. This ST and PQ, there is angle, some angle theta. So how to find it? PQ will be simply ST cos theta y, because as I just said that the shortest distance is nothing but, say I have two lines. If this I am taking, I want to find out, I have these 2 points, I have to find the shortest distance. So this is the shortest distance. So if I have line, so this shortest distance is nothing but the projection of this line on this. This is what we are finding. PQ is equal to ST cos theta. So cos theta will be what? PQ dot ST by magnitude of PQ ST. But we have just known that this PQ is D into n cap. We just found out. We can again write it here. But ST is what? We took it as A1, we took it as A2. So ST will be A2 minus A1. Just place it here, A2 minus A1. Right? So what we got? This is nothing but this was B1 cross B2. This is like this. This was B1 cross B2 by B1 cross B2 mod. And this is nothing but ST. Let us keep it here. So the required shortest distance, which is the D, is nothing but PQ, which is actually ST cos theta. Now multiply this by ST. You get this one. So this is the D. B1 cross B2 dot A2 minus A1 by B1 cross B2 magnitude. So in the Cartesian form, if L1 and L2 are line equation of this form, the shortest distance will be x2 minus x1, y2 minus y1, z2 minus z1, then a1 b1 c1, a2 b2 c2, this in the matrix form. That is, you have to find out the determinant of this and divided by the b1 c2. If you take a1, this will be b1 c2 minus b2 c1 whole square, and similarly for others also. Now how to find the distance between parallel lines? Now it becomes quite easy now. Why? Because now this B becomes equal because they are parallel. So if two lines L1 and L2 they are parallel, they are coplanar. They are coplanar. So they will have B as similar. So this A1 and A2 are the position vector of point S on L1 and point T on L2 on this T on L2 in this figure. So this L1 and L2 now they are coplanar if the foot of the perpendicular from T on the line this one L1 is P. So distance between L1 and L2 is what? This will be simply again the projection of ST on this TP. So if theta is this angle between ST and B, that is what will be the ST and B, just B and ST, just take the cross product, which this will be B into ST sin theta n cap. So let us find out the n cap, right? This n cap is the perpendicular line, is a unit vector which is perpendicular to both L1 and L2. And what is ST here? What is ST here? ST is nothing but A2 minus A1. This is A2 minus A1. So now just place it here, ST. B into ST is B PT. And we know that PT is nothing but PT sin theta, ST sin theta. See, what is this TP? TP is nothing but this sin theta. Okay, sin theta is perpendicular by hypotenuse. This is perpendicular and this is hypotenuse. So just place it, you will get the value of PT also ST sin theta. You can just directly place there. And this n cap, of course, the magnitude of n cap, if you take the magnitude of both the sides, you get this one, the n cap as 1. So what you get? PT, which is the distance, which is actual distance, divide this B here. So this will be B1 cross A2 minus A1 by mod of B. Now let us find out the shortest distance between these two lines whose equation are like this. So they are non-coplanar skew lines. This is A1, this is B1, this is A2, this is B2, and we know the formula directly. So just equate them with R equal to A1 plus lambda B1, and this is R A2 plus mu B2. A1 is this, B1 is this, A2 is this, B2 is this. Find out A2 minus A1, that is I minus K will come. B1 cross B2, just multiply or take the cross product, and then the cross product will be found out by finding this ijk in the, this is the actually determinant, ijk and these values of ijk, and then B1 cross B2 magnitude. So find out the magnitude of this, 3 square plus 1 square plus 7 square. This is the magnitude of this. Just place in this equation and you get, or this result, you get the final 10 by root 59. Now find the distance between the lines L1 and L2, which is given by this. See here, this B1 and B2 they are equal, that is these lines are coplanar. So we'll use this formula, B cross A2 minus A1 by the magnitude of B. So A1 here is this, A2 is this, and these are B. So just place it here. You can easily find out this B1, A2 minus A1 first you have to find out. 3 minus 1, 3 minus 2, and minus 5 minus 4, that will come here. And this is 2, 3, 6. This is of course the B is this, and A2 minus A1 will come here. Just find it out. I hope that you'll be able to do.